Hello and welcome. My name is Shannon Kemp and I'm the Chief Digital Manager of Dataversity. We'd like to thank you for joining today's DM Radio, Planets Align, the Irresistible Forces Pulling Big Data into the Cloud, sponsored today by Unravel. It is a deep dive and continuing conversation from a DM Radio broadcast a few weeks ago, which if you missed, you can listen to it on demand at dmradio.biz under podcasts. Just a couple of points to get us started. Due to the large number of people that attend these sessions, you will be muted during the webinar. If you'd like to chat with us or with each other, we certainly encourage you to do so. Just click the chat icon in the bottom right-hand corner for that feature. For questions, we will be collecting them via the Q&A section in the bottom middle of your screen, in the bottom right-hand corner of your screen. Or if you'd like to tweet, we encourage you to share highlights or questions via Twitter using hashtag DMRadio. And as always, we will send a follow-up email within 2 business days containing links to the slides, the recording of the session, and additional information requested throughout the webinar. Now let me turn the webinar over to Eric Kavanagh, the host of DM Radio, to introduce today's webinar and speaker. Eric, hello and welcome.
Hello and welcome back. And if you hand me the ball, there may be a latency issue. So, all right, folks, here we are once again, a DM Radio Deep Dive. Yes, indeed. This is your host, Eric Kavanagh. Planets Align, the irresistible forces pulling big data to the cloud. It's going to be an astronomical show today, folks. So let's go ahead and dive right in. So the Great Migration, I've been tracking this for quite a long time now. I actually have my own data that I've been watching very closely. I do all of the marketing, or it at least goes through me, for the Bloor Group, which is, of course, a partner with Dataversity in producing DM Radio these days and these deep dives. And I've been doing email marketing, tracked email marketing, for almost 20 years now, since 1999. That's right, the last millennium is when I started using this stuff. And I expected cloud to be a hot topic for the enterprise by at latest 2010, 2012, quite frankly. And it just wasn't. And I could tell from the numbers, raw numbers that I would get of open rates on email blast. Anything that said cloud in 2012, 2013, 2014, even into 2015 was just a snoozer. Nobody was interested. Everything, as far as they was concerned, was still on premises. It was around 2016 that things changed, and all of a sudden cloud became a pretty hot topic. And I'm now referring to this as the Great Migration. And what I'm talking about is it's real now. Enterprises understand and appreciate that cloud is real. You can look all over the place and see the major vendors jumping on board. But, of course, what's going to happen here? Things don't happen overnight, right? There's going to be a very, very long tail to on-premise applications and to on-premises data, right? Those data centers are not going to go away. In fact, I kind of predict that there's going to be a bit of a backlash. I think it's already happening, and you're going to see certain aspects of the enterprise really resist this movement into the cloud. CFOs, for example, chief financial officers, they don't want their data in the cloud. But we're going to talk about big data today, and we all know that data has gravity. We're going to hear from George Demarest here in a few minutes of Unravel Data, which is a really, really interesting company I've been tracking for a couple years now at least, doing some very cool stuff to enable the leveraging of big data. But like I say, long tail to legacy systems. And in fact, I used just yesterday a quote that I remember hearing about 5 years ago on DM Radio when someone gave me a definition of legacy systems. A legacy system defined as any system that's in production. I think that's kind of funny. So in the world of technology, we often think that cool things are new. In reality, they're often not very new. So I put together this timeline for enterprise cloud adoption, and it goes all the way back to 72, believe it or not. 1972, IBM rolled out its first virtualization technology. It wasn't until 1997 that Yahoo email launched. Who remembers that? Remember Excite email? Yahoo, a bunch of folks all jumped on that bandwagon. Yahoo, of course, has been sticking around ever since. Excite is still out there. There are people on Excite. Don't run across too many of those emails, though, quite frankly. It was 2006 that Rackspace released its cloud offering. The same year, Amazon Web Services. Well, goodness gracious, they made a tremendous foray into the cloud. I remember taking a briefing from them around 2011 and was amazed at how broad and deep their portfolio of applications was at that point. It's now 2019. Obviously, Amazon is the leader. They're absolutely a juggernaut. They are just kicking butt and taking names across the board. So in 2007, there was almost zero big data business in the cloud. It just wasn't there yet. The enterprise was not yet ready. And you can see in 2008, Project Red Dog. In 2008, Google Cloud Platform. That's when that was launched. Now, you didn't hear about it a lot until the last couple of years, but for those of you who are in the industry, I can tell you one bellwether that shows that cloud adoption for the enterprise is real for Google, and that's because they're going out and grabbing some of the best enterprise software senior executives, folks from Informatica, folks from Teradata, folks from some of the bigger vendors are going over to Google, and they're also going over to Amazon. So both of those companies are very, very serious about the cloud these days, as is another big company we'll talk about in just 1 second. 2009, Google Docs was released, and oh my goodness, how did that revolutionize collaboration? I love Google Docs. Of course, Microsoft also has now gone into the cloud. 2013 is when Docker was launched. 2014, Kubernetes launched. Most of the people I talk to say Kubernetes has won, and in 2016, I would suggest is the year that the Great Migration began in earnest. So there's Satya Nadella, Microsoft CEO. Why is he smiling? I credit Satya with really changing the vector of enterprise interest in cloud, because he put his company whole hog toward cloud with Microsoft Azure, and they have had a huge impact. The fact that they went all in on Microsoft Azure Cloud has really changed minds in the enterprise. I think that was the determining factor, quite frankly. And I do think it's kind of funny that we can thank Microsoft for saving us from the monopoly of Amazon Web Services. Well, cloud is now number one. That's a classic line from Jean-Luc Picard. Remember when he gets taken over by the Borg? It's real. Resistance is futile. I don't think there's any doubt about it. There are lots and lots of reasons for that. Think of the companies like Salesforce, for example. 20 years those guys have been around. It's now the tallest building in San Francisco is the Salesforce building. Of course, Mark Benioff came out of Oracle, so he cut his teeth there. Well, what does this all mean? You know, speed and performance is a huge factor. So if you have these sort of on-premise environments and you're trying to leverage cloud computing, you're trying to leverage Salesforce, you're trying to leverage some of the maybe marketing technologies that are out there. It's now the MarTech 7000, by the way. If you want to look that up, it's a very fun thing to explore. MarTech is in marketing technology. I think about 10 or 11 years ago, it was the MarTech 150. Then it was the MarTech 250. Then it was the MarTech 350. Then 500. Then 1,000. Then 2,000. Then 3,000. Then 5,000. And now it's the MarTech 7,000, meaning there are 7,000 companies doing sales and marketing automation as software as a service. That is a staggering number. It is a tremendous amount of data out there that you can leverage for your business. To get that complete customer view, for example, to understand what the market opportunities are, to get your messaging out there, to sell stuff. There's also this interesting dynamic of CapEx to OpEx, right? It used to be that we would get data warehouses built with capital expenditures. Millions of dollars would be set aside for an 18-month or a 2-year project to build an enterprise data warehouse. Well, companies like Snowflake have come along and just dramatically transformed that reality. And of course, Amazon Web Services with Redshift. I actually remember the company that whose technology became the kernel of Redshift, a company called Parexel. Barry Zane and Rick Glick, 10 years ago, were working on this technology. They struck a deal with Amazon. Parexel actually went away. Redshift is still here to stay. And that's a whole movement right now for data warehousing in the cloud, right? So there's another force moving us toward cloud computing. And I would suggest that these days of CapEx projects really are numbered. So this movement to the cloud, I'm suggesting, really should be a front and center, all hands on deck type of activity to make sure you get the right data into the cloud in the right fashion and you manage that process accordingly. So think about all the different major vendors that are in the cloud now: Salesforce, Amazon, Oracle, Microsoft Azure, SAP with its business cloud platform, IBM, of course, Google, the Google Cloud Platform, we mentioned that, Heroku, Rackspace, and there are more coming every day. The cloud is the new center of gravity. We're going to hear that in just a moment from George Demarest of Unravel Data. So I was thinking about how you manage these environments, right? This is actually a fun little slide, just an image of a bee with a transponder on it. IoT is such a huge space these days, the Internet of Things, being able to track all the different objects that are out there, whether it's cars or mobile phones, whatever the case may be. Think about manufacturing, think about oil rigs, think about all of these different use cases for the Internet of Things. It's a huge space right now, and there's a ton of data flying around. If you're trying to keep track of 10,000 vehicles or of 150,000 mobile phones or of 5 million mobile phones, for example. You've got a mountain of telemetry data flying around. Well, that's going to live in the cloud. I mean, let's just be honest. That data going forward, it's going to start in the cloud, it's going to stay in the cloud. Being able to manage all that stuff is going to be a real challenge. And I can tell you, and we'll talk about this for just a couple quick seconds here, systems management has always been hard. If you go back even 20 years or so ago, one of the main drivers for dealing with systems management was, wait for it, Christmas. Because the holiday season would have such huge spikes in traffic on these e-commerce sites. So that's where a lot of the technology that we get these days, like even if you talk about containers, for example, workload balancing, all these major developments in e-commerce and in web-based scalable applications and infrastructure really spun out of the holiday season because they needed some way to handle these massive spikes in traffic without choking off their customers to be able to sell their wares. So I just think it's fun that Christmas and the holiday season is really what helped us. But the point is that 20 years ago, systems management was difficult. 10 years ago, systems management was difficult. These days, when you start dealing with all of the major scale-out applications that we'll hear about in a minute, Kafka, for example, which of course spun out of LinkedIn, Kubernetes, all these different technologies, these scalable big data technologies, Hadoop, for example, even though we don't hear the word, Hadoop is still rocking and rolling out there. These are incredibly complex environments, and being able to do systems management, troubleshooting, workload balancing, being able to estimate the right number of servers that you're going to need, the right number of nodes to handle all this stuff, it's really difficult stuff. Typically, you're just looking at histograms, and it actually requires a whole lot of knowledge on the end user to be able to piece that stuff together. When CPU usage goes up, when there's a network bottleneck, for example, knowing why that happens, doing that kind of troubleshooting has always been very, very challenging. That actually got me thinking, I don't know if you all remember from calculus class, but in calculus you have to recognize the nature of the challenge, or the nature of the problem you're trying to solve, and then you apply the appropriate tool or the appropriate formula to kind of unravel that. There's a little pun for you. And it got me thinking, that's kind of like systems management, the way it's been over all these years. Well, something is changing, something big is changing. It's a combination of artificial intelligence and just some really clever architecture and really clever thinking on the part of some innovators. And I would suggest to you that systems management going forward is going to be a different game. So we'll talk about this on DM Radio all throughout the year in various capacities. AI is changing everything. Big data is a huge driver. And I would argue that the days of the old-fashioned way of troubleshooting and of managing complex information environments, the old days are changing and a new day is dawning. And with that, I want to hand it over to George Demarest of Unravel Data. Very, very interesting company doing some cool stuff. And George, I'm going to try to hand you the ball right there. And you now have the ball. Show us what you got, George.
Thank you, Eric. Thank you, everybody. Thank you for joining us. Eric, can you confirm you see my slide?
Yep, looks good.
Okay, there's me. Actually, if you move around, you'll see that my eyes follow you in that photo. So yes, I'm from Unravel. We are an AI ops company for big data. We do performance management and troubleshooting and all sorts of things for big data environments. So thank you for the opportunity to talk with you today. The topic is about big data moving to the cloud. There are a lot of reasons why generally people are moving to the cloud, but there are some particular forces at work that make big data especially suitable to running in the cloud, and that's what I'm going to talk about today. And then a little bit about some of that next generation intelligence that Eric just spoke about. So that alignment is, as Eric has said, is already underway. The most recent Cisco Cloud Index shows that by 2021, 95% of all data center traffic will come from the cloud. Huge growth in data center traffic. Also, a larger and larger proportion of companies that are either have cloud first or cloud only strategies. You have newer companies that start in the cloud and stay there. So this is already happening, and for all the reasons that Eric mentioned. It's the systems management is nicely taken care of in the cloud environment. It is simple to set up, or fairly simple to set up. So this is already happening. Cisco's projection is that cloud computing will replace traditional data centers within 3 years. Seems a bit aggressive to me, but you get the idea. This is the gravity that is pulling really all companies. But in the big data world, gravity is especially important. You probably heard people talk about the fact, and especially in big data, the data has mass, it has gravity, and there's also a certain amount of organizational and technological inertia about moving to the cloud. And people are spending a lot of time analyzing this. That people have come up with formulae about application mass based on data volumes and data density and CPU utilization and memory and disk usage. That the data gravity is a function of the mass of data and applications and the number of requests per second. Latency and locality of reference always are part of the equation, and just sheer data volumes. And then finally, because much of our data, right now most of our data, and in the future a vast majority of data will be originated in the cloud, that sensitive data that you spoke about from CFOs and whatnot will most likely, for many, remain behind the firewall in data centers. But big data is going to originate from the cloud, and so a lot of people are asking themselves, why am I moving massive amounts of data inside my firewall, especially data that's not particularly sensitive? I mean, if you have 10 terabytes of telemetry data, how sensitive is that? I mean, you need to write applications to make any sense of it. So, people are doing a lot of calculations about how much it costs to get data in and out of the cloud. And of course, the cloud vendors, they make it as inexpensive as possible to move data into the cloud, but you need to pay to get it out of the cloud. So there are also those types of forces at work that make moving big data operations and applications to the cloud. So big data itself is still fairly young. It has been around, and we know tons more than we used to know, but it really has to be remembered that really only 6 or 7 years ago did Hadoop come out of the shadows from Yahoo and companies like that, Google and so forth. That these types of technologies were used by just those web and cloud giants. And the problem is that when you get data volumes of terabytes or petabytes or exabytes, that it is basically data chaos. So what we try to do in IT, of course, is to create some order out of that chaos. And the first entrees into big data were really fairly, they offered one level of abstraction, and there were very specific use cases to search result indexing and counting. IoT is a later example, but lots of data just being organized and counted. So in the world of astronomy, especially before telescopes and before science, the constellations were a way to look at the stars and see some order in that vast chaos. In the big data world, it has grown up around, especially around open source projects, many that originate out of Google and Yahoo and so forth. And you can see them on your screen now: Apache Spark, Kafka, also the cloud providers themselves, but Impala and Hadoop and HBase and so forth. A whole set of constellations around the big data environment. And the problem is that in doing management and doing performance tuning and doing troubleshooting, there has not been a way to make the connections between the different components and how those connections affect performance until very recently. So this is an example of an architecture of distributed systems that new data applications are built upon. So a data ingest, data collection, batch processing, ETL, data prep, and then finally analytics, and more lately AI and machine learning and IoT and so forth. And so this, I mean, there are a million permutations of this, but a lot of people are looking at a big data stack like this. And it's in order to get order out of that chaos, like the universe. This is actually a 3D picture or a graphic of the known universe, but it doesn't really work unless you have the metadata. So that brings some order to the chaos of the universe, and something similar is happening in the big data world. The challenge is that when you have multiple distributed systems, so Spark, Impala, Kafka, Hadoop, all distributed systems, all trying to work together, clusters of clusters and so forth. So it makes it very hard to identify a root cause. Let's say my application has failed, or it's very difficult to define realistic SLAs because of this complexity in managing and tuning distributed environments. And that in turn makes it a lot of finger pointing between developers, architects, ops people, cloud providers, and so forth. So very hard to identify a root cause because there are so many contributing factors beyond just the distributed clusters, the multiple clusters. It could be container issues. It could be data and file formats. It could be some infrastructure hardware problem. It could be scheduling. It could be wrong network settings. You might have the data laid out incorrectly. There might be bugs in the code. So just to show you what is the really confounding nature of big data, it also makes big data a big area of frustration for CIOs because it's very hard to predict. It's very hard to know if you're getting the optimum performance out of your big data environment. CEOs and so forth, they love the idea of big data and machine learning and AI and everything it brings, but practically speaking, it is a very complex problem. It is a hornet's nest to navigate for IT ops people, for application architects, and so forth. So the other reason that people move to the cloud, of course, is just performance. If you take your largest computer, once you've run across that computing boundary and need more computing power, you're kind of stuck. So that is why clusters have always been, since I started my career with VAX clusters back in, I don't even want to say the year, that we've all known that clustered computing is the ultimate goal of computing. Tens, hundreds, thousands of computers working in harmony, working on compute problems in a coordinated fashion. It has been done on the macro level with SMP systems. How do you scale in a single machine? Then to small clusters, and now to the cloud. So, but the impulse, of course, is to amass compute power so that you can exceed the speed of any individual computer. So that is what you get in the cloud environment. In order to get acceptable results, or real-time AI, for instance, which is one of the hardest compute problems to solve. Also, scaling AI and machine learning to millions or hundreds of millions of users is, of course, can only really be addressed by distributed computing clusters. And that is the essence of big data. It is a distributed computing problem with distributed data. So I think people in the big data world all sense that we are heading in the inevitable direction of computing we've been working on for 20 years or for longer. So we have now the cloud that offers these clusters, and I know this will hurt your eyes for a bit, but just give me a second. Cloud vendors are providing a lot of tools and a lot of capabilities to make these computers run in an automated fashion, be able to spin up large clusters very quickly. But just automation of systems management is not enough, especially in the big data world. That it is increasingly clear that you need context with automation, and that means AI and ML. So some key areas of big data that require automation that is informed by AI are application auto-tuning. Application tuning, as I mentioned, hugely difficult, and if you have 100 applications running on a 1,000-node cluster, trying to tune individual applications manually is more and more becoming a fool's errand. There has to be better automation, and it has to be informed so that silly human errors or one tunable parameter set incorrectly, or the wrong Spark shuffle configuration or what have you, if that is not informed by better intelligence or an expert system like Unravel, then you're really in trouble. Same thing for root causing problems with a failed application. If you have a Spark application running on 20 or 200 or 2,000 nodes, you can imagine the complexity of trying to track down, code failures and improperly set memory boundaries, container issues, and so forth. I spoke before about SLAs in the big data world, and for a long while, really, even only 3 or 4 years ago, there was kind of a prevailing opinion in IT circles that big data just isn't a production technology, that it's either experimental or it will tolerate its failures because the potential gain, the potential new revenue streams, the potential for big data is so great. But nowadays, with big data becoming more proven, more relied upon, SLAs become a much bigger deal. And of course, your ops teams, they live in an SLA world. So SLA management, especially for applications with data in motion, streaming technologies, and so forth, if that is not guided by machine intelligence, also very difficult to get serious about SLAs for these increasingly important big data or modern data applications. Or how about optimizing the cluster itself? I mean, it's hard to, you get some basic usage information about your cluster, but what if you are able to monitor your workloads and have your cluster learn about those workloads and adjust itself, or make recommendations for you to reconfigure container sizes or cloud instance types or what have you? So a lot of different moving parts in a cluster, and trying to get the most out of the compute power, the memory, the data throughput really requires machine intelligence. And an example of how the running of big data and AI and ML applications itself and trying to tune them becomes a big data problem. That companies like Unravel are using data science and using machine learning, AI, and really a raft of other analytics approaches. AI is the easy kind of buzzword, but there are many different algorithmic and analytic approaches to for instance, auto tuning applications. So applying AI to root cause analysis requires collecting the data, creating the models, training the models, and then running against your production environment, creating a predictive models in order to be able to tune the cluster or the application or the stage of the application. So, in a modern data pipeline, it may be, 5 stages of Spark with some callouts to other processing engines and so forth. So creating a data model is becoming really critical in order to understand the running status of a cluster and of big data applications. And that, in the end, is what we do. So a little bit of a commercial for Unravel. I hope you'll pardon me, but Unravel is 5 years in with the DNA from Cloudera. We have PhDs from Duke University. Our founders, very smart people. We have input from Hortonworks people, from Cloudera and AppDynamics, and we are well funded. We have some great customers, and we have more than 50,000 nodes being supported now with our investors noted below. But our solution is, in a nutshell, performance management for modern data applications or big data. And we, unlike individual AI ops technologies that focus on a particular component or problem, we monitor and tune and automatically troubleshoot the full big data stack that I showed you before. We can use AI and other analytics technologies to monitor and optimize resources and costs. One of the things especially relevant to today's discussion is migration to the cloud from data centers. We have some specialized intelligence that can help you move to the cloud, and then, as I mentioned, automatic tuning and remediation. So that's Unravel in a nutshell. Here's our product architecture, which looks a lot like a big data application architecture, but you see on the left side that white box is our data source. Our data source are the applications themselves, the platforms and technologies, Spark, Kafka, Cloudera, Impala, Hadoop, NoSQL, SQL, etc. And even though our topic today is cloud, we support cloud environments, on-premise and hybrid and multi-cloud environments. So same product across all of these environments. And what we do is we collect, in a very efficient way, data from all of these environments in our data collection process. We then build a correlated data model that is a dynamic data model that is constantly being updated depending on the state of the cluster and the state of running applications. And then we have a number of intelligence and automation engines that we apply to that data. So running analytics I've spoken about, we have an automation engine, we have a tuning engine, and an inference engine. And you'll see, I'll show you a couple of screenshots that we actually make detailed recommendations for Spark and for MapReduce and for Hadoop and so forth. And then finally, the output of all that automation and intelligence is displayed in dashboards, or we can take automatic action to auto-tune applications or to kill a job if it's running crazy in the cluster. We can do smart alerting over Slack or PagerDuty or email. We do reporting. And as I mentioned, we give very specific recommendations on running applications and the cluster operation environment. So that's our architecture. Like I said, it looks like a classic big data pipeline in a sense, and that really is what it is. We are a big data company tackling big data with AI and ML and other analytics. So just to show you the problems we solve, I spoke about APM for big data. We also fall in this AI ops category that Gartner is speaking about, but specifically for the big data environment, the full stack. I mentioned cloud migration, optimization, and troubleshooting, so I think I've covered this a little bit. But let me show you specifically what that looks like. So from an application context, the screen grab on the left is actually the auto tune pop out from the product. You can see the tuning recommendations on the top right. So MapReduce parameters, Spark parameters. We give you recommendations for the optimum value, not just based on a set of rules, not just a rules engine, but also based upon the running characteristics of the application. For instance, Unravel has a feature called Sessions, and what that does is it enables you to run your applications, your big data applications, a number of times, and we will progressively collect more and more data so that we can make more and more targeted and accurate recommendations and auto-tuning of that application. We provide error reviews and all sorts of analytics that I just don't have time to talk about. But then we also look at the operational level of the cluster. So we do cluster optimization. You can see here a recommendation for Hive queries. We also provide predictive capabilities, capacity planning, and forecasting. So that is especially important for the cloud, as I'm going to show you in 1 second, but also helping you understand how much compute power, but also how much you're spending, either on-prem or in the cloud. And this here are the cloud capabilities in particular. This is only one kind of one sort of angle on Unravel, but it's very specific to clouds. That's why I have included it. And so what we from top left, in order to really do the best job of migrating your applications, Unravel helps you understand your current on-premises workload. So you can run the Unravel cluster discovery report and get a readout of, how many cores, how much memory, how much data is running in your data center. And then we can provide some analytics to clue you in on which applications are the most likely or the most profitable, if you will, to move to the cloud. So, for instance, apps that are bursty or apps that have fail all the time. Maybe they're contending with other applications in your cluster. So the cloud gives you the ability to isolate applications, and that's a good reason why bursty applications or resource hog applications are good candidates. We can also show you chargeback reporting. That's the third, the center. You can see the colorful circles there by application, you can tag your application, so it can be by department, by users, by so forth, very configurable. And then we provide even intelligence to map your on-premises cluster to deployment in the cloud, and that includes AWS, Azure, and GCP. So we can give you some recommendations on which cloud instance types, how many nodes you need. So that calculates the number of vCores and the amount of memory available to you. And we give you a number of different looks. If you want to just do a lift and shift to the cloud, we provide you guidance. If you want to optimize for cost, or if you want to use our advanced analytics and AI to right size it for your particular workloads, we provide that capability as well. And then finally, some of the classic APM capabilities we do enables you to track the migration and its success and how much you're saving and so forth, and also, of course, application usage of cloud resources. So you always know which users, which applications, which data pipelines, so forth, are using the most resources and so forth. So that is a look at what Unravel looks like. Just to kind of sum it up, the benefit of having AI applied to big data is that it removes the blind spots, removes the unknown unknowns in the big data ecosystem. That means that troubleshooting, which in the big data world, it's not unusual for troubleshooting and debugging to take weeks or even longer. We have customers that have cut down their troubleshooting time so drastically, literally from weeks to troubleshoot what might turn out to be a simple configuration problem with Kafka or Spark, to instant results to show you, oh, that user is allocating way too much memory, or your container sizes are way out of whack. Some things that you can eventually figure out, but isn't it better if you have an AI tool like Unravel to help you? So 98% reduction in troubleshooting time. You can set SLAs and meet SLAs, and Unravel will actually even give you recommendations on, okay, I need to hit 100% of my SLA, or 95 or 80 or whatnot. Sometimes you can tolerate a little bit of SLA violation, and Unravel enables you to be very custom about your SLAs. And then that eventually means that if you're getting the most out of your cloud resources and you're basically getting optimum usage for your compute power, for memory and data and so forth, that your cloud costs are going to be sensibly reduced, and by, in many cases by orders of magnitude with our customers, but easily by 60% across the board. So that is Unravel, and that really kind of brings us to the end of the prepared section of this presentation. The planets are aligning for big data in the cloud. The irresistible forces are, of course, the gravity, the mass, the fact that it's expensive, difficult, and slow to move data around. So because data is being originated in the cloud, a lot of people are going to elect to leave the data in the cloud and have the processing done there. Finally, clustered systems are great. We know that there are in the close to probably 10,000 big data, huge clusters around the world. That in the next probably 5 or so years is going to multiply, that many more customers, yourselves probably included, are going to be running much larger clusters because the automation and the intelligence will be there to go faster than the speed of light. And then, so that's really where we fit in, and that's those are the irresistible forces pulling big data to the cloud. And with that, Eric, I've kind of ended my section of the presentation. What do you got?
Sure thing. So it seems to me that the obvious selling point here is the remarkable complexity of these environments, right? You're just not going to be able to use traditional systems management technology to be able to track across these clusters because A, there's so much data, but B, there are so many potential variations, and that's why you want algorithms running in the background all the time, tracking all these developments and finding the signatures of problems, right? That's really kind of what it boils down to, is to find the profile of a particular issue, save that, and then you recognize it next time it comes around, right?
Yes, exactly. It's the problem is just becoming too big for manual intervention, and I think most people know that the end game of automation is so you can do more. And with big data, you're talking regularly now about hundreds or thousands of cluster nodes, and it's just not practical anymore to manually intervene. You need high levels of automation that are guided by machine intelligence.
Mm-hmm. Yeah, and back to that calculus metaphor, it seems to me that this is the answer for kind of moving us beyond that phase. Because unless you're a math genius, calculus is actually pretty difficult. And I would argue that systems management, even with some of the best technologies a few years ago, was very difficult because, again, you had to have an end user who could really understand what the spike in CPU usage means relative to this bottleneck in network traffic, relative to this disk fragmentation issue or whatever. You would just be looking at histograms and trying to piece together in your mind what all that stuff means. Whereas by leveraging AI under the covers, you're able to scan. I mean, you talk about sessions. We should maybe go into that for a little bit. You're able to scan these environments hundreds and thousands of times and look for patterns and variation and spikes and valleys and so forth. And it's always in those strange seeming anomalies that you're going to find the trouble spots. But again, a human being trying to do that manually, it's just not going to happen, right? Can you talk about the importance of sessions and the importance of gathering so much data and being able to analyze so much data at scale?
Yeah. So that I'm also looking at the question that came in talking about the cloud being, being appropriate for applications with data spikes and so forth. The challenge is that CFOs and CEOs and CIOs to a degree, they're more and more being directed that either cloud first or cloud preferred or cloud only. So that really all kind of points to the same thing, that the people need to make cloud as fundamental to their IT strategy as any other IT technology.
Mm-hmm. And we talked about the Martech 7000 just briefly. And for those who aren't familiar, again, that's 7,000 different applications for sales and marketing optimization. There's a whole bunch of new stuff these days, like influencer marketing, for example. But just think about tapping into the Twitter API or a Facebook API or the LinkedIn API, for example. And for those who don't know, Kafka came out of LinkedIn. So Apache Kafka was the engine that actually drove LinkedIn. It's a giant messaging bus, basically. And all of these big data environments have their own unique architectures and their own signatures, so to speak. So what Unravel is able to do is basically tap into lots of these different environments and give the end user, the company that's leveraging this technology, a view that sort of single pane of glass across incredibly diverse and topographically disparate environments, right?
Yep, for sure. So I see another question, Eric. Do you want to read the question? Or you want me to read it?
Sure, I'll read it out. So with much of the management being done by the cloud provider, is Unravel as useful in the cloud as it is for on-prem data centers? That's a good question.
Yeah, so want to re-emphasize that we are not a systems management company. And we do stuff we do collect intelligence around the infrastructure. But the cloud providers do provide some great systems management tools and monitoring of that environment. We are also not just a monitoring technology. We are focused on the automation and also collecting intelligence about running applications, and they may have many different components. The Kafka might be HDFS, might be MapReduce, might be Spark, might be Tez, might be lots of different big data components, and none of the cloud providers are providing any kind of real intelligence about that many components, much less trying to correlate their behaviors and their performance. And that is what that is for one thing, we know for sure it's a very difficult problem. Takes a lot of engineering, takes a lot of of intelligence to do that. So yes, the cloud providers do systems management and they do some monitoring, but they're not going to auto-tune your data pipeline that may have many different distributed components. And even the individual management components from big data vendors themselves, Cloudera and MapR and Hortonworks have some nice tools to monitor Hadoop and the cluster environment. They are not doing the cross-environment kinds of intelligence gathering and automation and auto-tuning that we do. So we're pretty unique in the industry. And we started out as basically an AI for Hadoop technology, but we have branched out now to cover the entire big data stack, and we are adding new engines. So you'll see some new stuff coming out of Unravel that monitors AWS technologies, that monitors Azure big data technologies. I can't pre-announce them, or my product manager will kill me. So the nice thing about our approach is because it's really kind of a big data approach, we can continue to add engines and we can continue to add finer grained intelligence about Spark and about Kafka and about HDFS and so forth. So we can go very deep and provide a very high definition picture of your environment that you just can't get other ways. And the debugging of those types of environments means, pulling down systems or application logs and other operational metadata from the cluster itself, and garbage collection and JVM stuff, and all that stuff is analyzed by Unravel, and as far as we know, no one else is kind of doing it the same way.
Yeah, and I'm reminded of a couple of things. One, you mentioned Spark a few times, and Spark, of course, really took the industry by storm a number of years ago and provided a tremendous framework for leveraging big data applications. But Spark has its own challenges, right? I mean, memory usage is a challenge, and when Spark jobs fail, typically they're failing in really serious critical environments, right? So being able to understand the nuances of when Spark will fail, of when these jobs will not complete, that's really important for keeping everything running. I mean, you talked about troubleshooting going down by 98%. I mean, that's just a staggering number. But the key is that because you're collecting data from all of these different data points and because you're able to then correlate them, and again, in the background, use machine learning to scan over and over and over again. And remember, with a lot of these technologies, you'll be able to identify the profile of very complex problems, and then over time you're kind of building up a repository of signatures. Is that right?
That's right. That's really behind the data model I spoke of. So that as we learn more and more about the Spark environment, Spark as a platform component as well as running Spark applications, then we fill in more and more of the picture. And given that Spark example, and anyone who's been dealing with Spark knows that a lot of failures are really from, kind of mundane things like, improper memory management, or just, shuffle boundaries and things that, if you checked beforehand, you might be able to catch, but oftentimes, especially if you have a portfolio of dozens of applications you need to be running and managing, a lot of these things just won't get caught. So that's kind of the, removing human error part of AI, that there are simple things that are, and some not so simple, but things that are very commonplace, and Spark failures, as I mentioned, and Spark slowdowns are often the result of very mundane things, or just not great behavior from app developers or what have you. And unfortunately, for a long time, it has been a trial and error type of situation for people to size containers, to allocate memory for Spark processes and so forth. That is the type of thing that just needs to be automated and have people not worry about, and that is our goal. Yeah,
right. And I'm reminded that I wanted to include a slide with a picture of the the Eagles album Hotel California just as a metaphor for getting data into the cloud, right? You can check out any time you like, but you can never leave. Well, you can pull your data out of these cloud providers, but that's when they tax you, right? It's on the egress. And so here again, it's really important to understand in terms of your cost projections and your total cost of ownership where you're going to be moving data. And it's really important to have that sort of cross-landscape view. And that's where I see Unravel having a really nice advantage because you can peer into all these different environments. And I've listed, I think, 10 or 11 major cloud environments these days. And to your point, when you stitch together 4, 5, 6, 7 of those different environments, the complexity goes right through the roof. And there's just absolutely no way a human being is going to be able to handle all that stuff. And so a technology like this that can, again, leverage the power of machine learning to scan these systems and scan and rescan and notice the disparities, notice the spikes, notice the anomalies, that's going to be key for making sure that your big data applications continue to run, right?
Yes, and add a level of complexity on top of that we're seeing more and more people wanting to run hybrid cloud and multi-cloud environments. So it's not like every customer is running just on AWS. They're running something in the data center, they're running something on AWS, something on Azure, and something on Google, and that becomes a logistical nightmare. So we are the same product on all those environments, and we can collect intelligence and make recommendations and auto-tune on all those environments with the same code, the same product, the same UI. So that is an additional level of complexity along with the complexity of a modern data pipeline.
Mm-hmm. And I was impressed to hear that number you threw out there, something like 90%, 95% of data center traffic in the future is going to be in the cloud. It's interesting. We went from talking hybrid cloud, and I think about 4 weeks later, it had switched to multi-cloud because that's the reality. I mean, if you look at, for example, SAP going all in on S/4HANA, which is ERP in the cloud, in memory, very, very intense environment. Can you guys see into SAP's S/4HANA as well?
Not currently. But as I said, the architecture of Unravel means that we can really analyze any environment. I mean, if we wanted to do MySQL or some mundane technology, the architecture supports it. So who knows in the future? I mean, we're still fairly young, but we have done a ton of work, and we cover really. We've done a lot of research on who's using what out there today in big data, and we think we have great coverage. It does evolve, and there are interesting technologies coming out of Amazon, Google, and Microsoft. So we are partnering with all of those companies. So just kind of watch this space because you'll see some more interesting cloud news coming from Unravel in the future.
Yeah, and I'd like to throw one more last kind of a bigger question at you. Through the history of this environment of this industry and certainly the Dataversity crowd, we have technologies like data warehousing that I mentioned early in the webcast here, business intelligence, for example. All of these disciplines revolved around a single premise, which was that we can gather our data and get a better idea for what's happening in the world and fuel some insights that we can use to make some better decisions. There is this whole new approach of tackling that. I refer to it sometimes as real-world data at scale, or some folks are talking about it as alternative data. So there are lots of examples of this. You saw this kind of early in the Hadoop movement of companies using satellite imagery, for example, of traffic patterns going to shopping malls and using that to determine roughly what the footfall is going to be in the mall that day and roughly what the projections are going to be. We're going to see more and more of that kind of activity where big data at scale is leveraged. And that's a whole different way of viewing the world, right? But again, it's going to require tapping into all these big data environments and being able to unravel them, so to speak, and understand what's going on. Do you see that as a pretty significant market trend going forward, this sort of alternative data movement?
Certainly, it's. I think people in the big data world understand that you touched on data warehousing, for instance, and so data lakes and data warehousing are often the very first big data use cases because data warehouses are expensive. So if you can offload, let's say, the ETL portion of your data warehousing process, that could save you millions of dollars. And data lakes, basically become, a macro data warehouse, if you will, this huge collection of data that you then apply structure to. I mean, that is really the process of big data developers and architects, is taking all that data and providing structure to it. So the tools, until recently, just haven't been there, and the understanding of machine learning and AI has just come on in leaps and bounds in the last 5 years. Same with data science. So yes, there's so much untapped potential in big data, and now the tools are becoming available to really become very, very imaginative. So as I said earlier in the webcast, I think people in computing have always thought that, clustered, coordinated computers that are intelligent and self-tuning and self-maintaining and lights out data centers and so forth has always kind of been the goal. But now it actually looks like we're on the horizon of being able to tackle these much more difficult problems. But in the end, it's going to need those new advanced technologies in order to make those advanced technologies successful in the end.
Yep. And with that, I'm going to hand it back to Shannon Kemp. Thanks so much for your time today, folks. Great presentation. Thanks to Unravel Data. Shannon, take us out.
Eric, thank you so much. George, thank you so much for this great presentation, and thanks to Unravel for sponsoring today. Just a reminder to everybody, I will send a follow-up email by end of day Friday for this webinar with links to the slides and links to the recording of this session. And thanks to all of our attendees for being so engaged in everything we do. We just love the questions and that have come in. And thanks, everybody. George, Eric, thank you so much.
Bye-bye.
See you guys.